All right, hello everyone. So today, let me turn my mic up just a little bit. Today, we're primarily going to be discussing sets and maps. We're going to start our introduction on testing. Originally, today was going to be fully testing, but I'm going to bleed testing into today and tomorrow, and I'm shortening the segment on software life cycles to a fraction of a lecture rather than a full lecture, just to keep us kind of on schedule for some other things. So, this, I need to change the font size just a touch. Let's go down to 18. See, there we go. That works. So with that, homework one, as a note, because we lost a day, I am making it due tomorrow rather than what the schedule originally said, which was tonight. Homework one is submitted on Colab. If you haven't tried to submit yet, I encourage you to at least start trying to get to a point where you can submit tonight. That way, if you have bugs, you can always come to office hours tomorrow and we can try to work through them together. Quiz 3 was released today rather than last Friday, so I've shifted. Did I not? Did I say webcat? I think I meant to say webcat, and if I didn't say webcat, which is very probable, because I mix up words in my brain a lot. I did mean submit to webcat. I would try to submit the webcat tonight, and then from there, try to fix it. Sorry if I didn't say webcat. That was a mental typo, in so much as you can have them. Homework 2 will be released tomorrow. It will be due next Monday as opposed to later this week. That's because if I move the homework 1 deadline, I need to move the homework 2 deadline. I don't want to make homework 2 due the same day as the exam. So quiz 3 is covering material from actually last week and today. That's what quiz 3 is covering. So specifically objects, and then what we end up covering today, that's what will be on the quiz. And that includes array lists too. So the exam, this was something that what I plan to do with the exam is I plan to make it available for a 12-hour window. That 12-hour window will start at noon and end at midnight on Friday. Now, I want to be very clear about that, so let me just put that on my notepad file. I think on webcat it shows the homework is due tonight. Let me take a look at that. Thought I made it due tomorrow. Oh, it does say the 22nd. Okay. Well, now it's fixed. I fixed it. How long is the exam? No idea. It's gonna be about 2 hours long. That's how long it's gonna be. All right, I'm getting too many questions for me to handle right now, so let me just address them one at a time. If you've already asked a question, wait until I answer the question before asking another, just because there's already more questions than I can handle. I'm not going to answer what is on the exam. I'm not going to answer how long the exam is, because I've already answered that. It's 2 hours, and it's everything we've covered from now until the midterm. Midterm, Friday, available from noon to 11:59 p.m. 2-hour duration. To be very, very clear on this point, and if you mess this up, I'm sorry, because I'm telling you now you cannot mess this up. The exam will end either 2 hours after you start or at 11:59 p.m. Let me change the dimensions of this. Whichever comes first. So if you start the exam at 10:30 p.m., you get an hour and a half. That's it. You do not get the full 2 hours. So you should not wait to start it that late into the night. The exam will be on Colab. It will be similar to quizzes, a lot of multiple choice questions, a lot of form questions, except there will be coding portions of the exam. Those will be on Colab as well. I won't be using a website that we've used in the fall or spring called Ford. I'm just going to put the coding questions directly on Colab. We'll talk more about the exam the day before the exam, but I just want you to be able to plan your schedule. I'm not going to say anything else about it until now. Do we have class on the exam day? That's mentioned on the schedule. That we do not. So that is on the schedule page. So does that mean the final will follow the same format? Not sure yet. With the midterm, I can technically make up whatever rules I want. With the final exam, I'm still waiting on the dean to get back to me. And they have not gotten back to me, and I have been as annoying as I can be, and I have not gotten a response. So I can't make up my own policies for the final exam. So, today, are we expected to comment code? You are always. I will literally never tell you the phrase. You don't have to comment code. That phrase will never leave my mouth, except to say I will never say that. And the simple reason for that is you should comment your code to make your code easier to read, and that will help graders. That is not to say we will be grading on commenting on the exam, but you will never hear me say the phrase, no, you don't have to comment your code. It's just not something I say, because by commenting your code, it will actually make it easier for us to grade. And if you don't comment your code, it's harder to judge intent, and you may lose more points for an error just because we don't understand the thought process. All right. To that end, so today, real quick, here's the updated schedule. The updated schedule is on the course schedule page on Colab. If you check, all the assignment deadlines have been updated. Homework 1 due tomorrow. Homework 2 is released tomorrow, due next Monday. Homework 3 similarly has had an adjusted deadline. It's due the Monday after, or no, it's due later in the week. I think it's due Wednesday or Thursday. I can't remember which I did. Quiz 3, though, due tomorrow. Quiz 4 will be released on Wednesday. It will be due Thursday. Midterm exam still Friday. So with that, today we're going to be covering collections, specifically sets and maps, and then we're going to do a brief intro to testing, which is mostly going to be covered in lecture tomorrow. Is Thursday lecture up on YouTube? If it's not up on YouTube, which it should be, but you, just to show you this, you can always see. Oh, hang on. Sorry about the sound there. You can always see the lectures if you go to my channel and just click on Professor McBurney. Go to videos. Here's recent broadcasts. You can see that this one was 4 days ago. This is the Thursday lecture. There it is, in its entirety. If it's not on YouTube, which I believe it is, but just so that way you know where to find the videos. I'm pretty sure I had uploaded it, but checking. The videos may have been uploaded out of order, but yeah, no, it's there. It's on YouTube. It has 13 views. It's just the videos are out of order. So if you look at my YouTube channel at the moment, I think for whatever reason, I think it's just because Wednesday uploaded faster. You can see, like, here's Wednesday, here's Thursday. Apparently, I just make this expression with my mouth a lot. 3 different, actually 4. Anyway. So it's there. So, are there any questions, any other questions, before we jump into lecture today? And just to clarify the comment expectations for the homework. How and when should you comment? You should always use block comments before every function. You should use a block comment at the start of the class. You don't need a block comment for each field attribute, but you do need a comment to explain what it is. Approximately one comment for every 5 lines of code, roughly. We're not going to exactly enforce that. We're not going to count the number of lines, but visually your code should have reasonable comments for each block of code. So with that, today we're going to briefly talk about the collections framework. That's right, I'm actually using slides for a second. There's a number of classes that Java provides that are used to store things, and there's more than 3. There's 3 types. There's list, there's sets, and there's maps. Now, a list is not a class, rather it's a description of what a class should be to be a list. So an array list is an example of a class that lets you store things. A list is abstract, and we'll talk more about that, especially as we get into inheritance later in the week. But the idea is, we've talked about lists. They are used to maintain a list of items in an order. So for example, when we create an array list, which we're gonna pull up clips here. When we create an array list, oops, I have the, there we go. We create it and we add things such that they always have an order. So integer numbers equals new array list. And then from there, numbers.add 5, numbers.add 3, numbers.add 7. These are added in the order that we add them. And so if I were to print the list, it prints in the order that I added the elements. Now from there, we talked about how I can also add elements not at the end, but rather anywhere else. So I can do numbers.add 1, and let's add 18. That adds the value 1 such that it's at index, the value 18 such that it's at the index 1. And there you see, the idea is there's an order. There's a first element, 5. There's a last element, 7. And then there's index 0, 1, 2, and 3. That idea of order is essential to a list. And the key is that the list actually describes a group of containers. There's the array list, which we've mostly worked with. There's also another one called linked list. And if I change this to linked list, you'll see that, and I need to import it here. You'll see that this code works exactly the same, at least externally. This is still a list, still the first element, second element, third element, fourth element. Now, we're not going to get into today how the linked list works. I'm not interested in that right now. I don't expect you to know. But what you should recognize is that this idea of a list is abstract. There's 2 different implementations. In fact, there's several different implementations. There's one called a vector, for example. But this idea of a list is simply a set of elements in order. Some facts about a list: you can have duplicate elements. Numbers.add 3. If I print this, doesn't matter if it's a linked list or an array list, I can have duplicate elements. That's going to be relevant in a second. And in fact, there is a class, although it's not really a class, it's an interface called list. And list is an abstract class. Abstract meaning it's not a real class. We can't instantiate it, we can't run it, we can't build it, but we can treat something like a list. The same way that we can treat every class that we create like object, capital O object, we can also treat any list, linked list, array list, vector, like a list. So this is valid code. And the nice thing about this is I can change at any point I want what kind of list this is, and I don't need to change any of the code because the interface is the same. The way to describe this, the way to think about this, is just how many people here, and say yes or no. I want everyone responding. Yes or no. Yes, I have driven a Tesla. No, I have not driven a Tesla. Very, very quickly. In chat. Yes, I have driven a Tesla. No, I have not. Alright, actually, so far entirely no. Okay, I have not driven a Tesla either. Alright, I'm going to put a little delimiter here. Oh, alright, let me try again. Alright, now, what I want you to do is I want you to type whether or not you... Okay, no more posts. I need to put a delimiter because I want to separate, because I'm going to ask 2 yes or no questions. The second one is, how many of you, if given the opportunity, are convinced you could drive a Tesla? Yes, you think you could. No, you think you could not. Almost everyone. Why? Why do you think that you can drive a Tesla? Why, when none of you have driven it, are you so convinced that you're going to be able to just hop in the driver's seat and drive a Tesla? Why are you not worried about that difficulty? It's still a car, exactly. It drives like any other car. Now, the way a Tesla works is completely different from an automobile that uses gasoline. A gasoline automobile, when you press the accelerator, it opens up, it lets more fuel and more oxygen into the engine, creating a bigger explosion to drive faster. That's how a gasoline engine works. How a Tesla works is something electricity. Probably. Maybe. I don't know. The point being, though, the interface is the same. What is the interface of a car? It's a steering wheel, it's a gas pedal, and it's a brake pedal. I don't know how to mime gas pedal and brake pedal. I moved my foot, but you couldn't see it. The interface is the same. The interface doesn't change. And the interface of an array list is the same as the interface of a linked list. They have add, they have contains, they have remove. The fact that they're different under the hood is irrelevant to how you use them. And so that interface that they both share, we call that list. And then you have array list that's implemented one way and linked list that's implemented another. They work very different under the hood, but you use them exactly the same. And that's the idea of abstraction. The fact that the Tesla mimics the interface of the automobile, gas pedal, brake pedal, steering wheel, is done so that way people can quickly jump in and drive it without having to learn a new system. And that's what we're doing here. Now, these are both built into Java. Are there any questions about that, by the way? Does anyone not understand how a list is both an array list and a linked list in this context? That's the basis of the collections framework. So from there, jumping back into the slides, we have two other types that we're going to look at today, sets and maps. And again, the set and the map are abstract. They are implemented different ways. But the idea of how a set and a map works is more broad than any one implementation. And the idea of a set is we are most interested not in order. In fact, order does not matter in a set. Rather, we are interested in membership, whether or not something is inside of a set or not. And then with maps, You can think of it like a lookup table, which we'll get into some examples of what I mean by that in a sec. So first, sets in Java. A set is a collection of items that is unordered, and all the items are unique. There is no first and last element. But all of the items inside the set must be unique. So what kind of operations do we need? Well, we need to worry about how to add, remove, check if something's a member, and we need to worry about how to combine sets, union, intersection, etc. And Java gives us two implementations of a set, hash set and tree set. And exactly like array list and linked list, they have the same interface, but the way they work under the hood is different. Hash sets are faster, but tree sets support this idea of making your set sorted. It's still not ordered, but it's sorted. And that may seem weird, but we'll get to what we mean by that in a second. So this is an example of how we would create a set. But the key is, sets do not allow for a description of position. There is no index in a set. So, quickly, let's jump into Eclipse and let's do set string, and for now I'm going to say hash set just to avoid confusion. Hash set string words equals new hash set string go. From there, I can add words.add hello, words.add goodbye, words.add banana, words.add bandana. For now. And let me just add one more word that I'm just going to come up with on the spot. Spaceman. And you may think, okay, this looks like a list so far. But system.out.println words. Oh, unless I'm very unlucky, and there's a 1 in 20 chance, a 1 in 120 chance that I'm unlucky. Notice that the words that I added are not in the same order that I added them. Hello is the index 3. Index 3, we'll get into, there actually is no index in a second. Words.add goodbye, that's 1. Banana is 0. Bandana is 3. Spaceman was last. But notice this order is not reflective of the order that I added elements in. Why is this? Well, that's because a set doesn't have order. Further, there is no get function. I cannot do system.out.println words.get 0, for example. This doesn't exist. And that's because this actually is not index 0. This actually is not index 1. There are no indexes. This is unordered. That means the only way to loop through a set, the only way you can loop through a set is technically with something called an iterator, but we're not going to get into that yet, with a for each loop like we've done. So for words in, let's do string word in words, system.out.println word. That's the only way to loop through the set, because there is no index. There's a thing to note here. It also doesn't allow duplicates. Words.add hello. If I do the same print statement as before, system.out.println words. How many times is hello going to appear? Only once. Hello does not appear twice. And that's because every member of a set has to be unique. It can only appear one time in the set. So so what happens with add when I try to add it? It doesn't crash. Instead, I want to note something. If I print the output of words.addHello the first time, and then I do the same thing down here. Oops. I print adding hello the second time. I want you to watch what happens. The first time I add hello, it says true. The second time I add hello, it says false. What is happening here? Why is it true the first time and false the second time? Why is it true the first time but false the second time? Any guesses? There we go. It didn't add hello the second time. It didn't add it. And in fact, the add method is not void. The add method is Boolean. And by the way, this isn't just true for sets. The add method for all collections being list, set, and maps, is Boolean. Now, we always, in a list, always allow an element to be added. If I create an array list, integer numbers equals new array list, numbers.add 5, numbers.add 5. If I do that twice and I print the result, you'll notice that it prints true both times. That's because this method is also Boolean. And in fact, no matter what, when you call the add function on a list, it will always return true. That's because add is actually, you can think of it like a request. I would like to add this thing to the collection. And lists always say yes, because lists can have duplicates. They just create more space. It's fine. Sets are a very exclusive club that only let one of each element into the set. And the way it checks whether or not an element is there is with an equals method. Now, similarly, the set has a couple other functions you're familiar with. System.out.println words.contains hello, and system.out.println words.contains let's go with snail. The first one is true, the second one is false. Now, these methods do not change the set. Nothing changes as a result of checking contains. Whereas when we call add, something could change. It returns true if the set changes because we successfully added the element. It returns false if the element is already there. Are there any questions so far? Okay. Finally, system.out.println words.remove hello. This is going to print true because the element is in the set to be removed. If I try to remove it a second time, it's going to return false. So I get true and false. Is there a way to do add in one line instead of a new add each time? There is a function words.add_all, but there you have to pass in a collection like a list, and it will add each element one at a time. generally when we get into examples of how this is done, you call add inside of another function, maybe, or inside of a loop. Is a set abstract? A set is abstract. A hash set is not. So I can do set string, and I need to import set, but otherwise this works. I can say set string equals new hash set. The hash set is concrete. It is a particular implementation. Concrete just means not abstract. So a hash set is a particular implementation of a set. And set is the interface. And set describes how the sets describe every collection where there is no order and duplicate elements are not allowed. Now, there's another implementation of set. And it is different. So first, take a mental note. Banana, goodbye, bandana, hello, spaceman. From there, if I change this to a tree set, what does it mean for something to be abstract? So again, going back to my metaphor I used earlier, because this is why I laid out the metaphor. The idea of how a car should drive is abstract. The fact that we take that interface and put it into a gasoline-powered car, or a hybrid or an electric-powered car, that interface is the abstract idea of this is what a steering wheel should do, this is what a gas pedal should do, this is what a brake pedal should do. How it actually works, how the gas pedal works, how the steering wheel works, etc., may change from vehicle to vehicle. But that idea of what each thing serves the purpose of is abstract. So a set describes how an add should work, how it should behave. Remove, how it should behave. It doesn't say how it's implemented. No. So, well, sort of. So you can have concrete classes. That is every instance of... So, like, if I had a class called gasoline-powered car, every instance of that is a gasoline-powered car. So, in that case, gasoline-powered car is not abstract, because we can make gasoline-powered cars. I don't want to introduce the term stack and queue, because that's actually something I teach later, and I don't want to confuse people. So all I can really say is kind of go back, look at that example, think about it, do the reading, and that will kind of get you to the better understanding of what abstract means. But just understand, hash set is not abstract, set is. Because you can have non-abstract classes and abstract classes, and we'll get into that on, I believe, Wednesday. That will be part of homework 3. Anyway, let's now change this to the other kind of set. Not the hash set, but the tree set. And I want to ask you... I have to import, sorry. I want to ask you, does anyone notice anything about the print order of tree set? Anyone notice anything? It's alphabetical. So a tree set works like a hash set. It has add, it has remove, it has contains. It also has no indexes. There is no index 0, 1, 2, etc. It also only allows unique elements. A tree set only allows unique elements. But the one difference that it has is that the elements are sorted. And that may sound weird. They're sorted, but they're not ordered. Remember, ordered means there's an index 0, 1, 2, 3. There is no index 0, 1, 2, 3. There is still no words.get 0. That does not work with a tree set either. But anytime you iterate through, that is step through one at a time, a tree set, it will step through the elements in order. A hash set doesn't do that. So why would we ever use a hash set if a tree set always does sorting? Well, the reason is, and we'll get into how we measure this later, But hash sets are faster. They're actually the fastest type of collection for add, remove, contains. They are faster than an array list, substantially. Tree sets are faster than lists, any implementation of a list, but slower than hash sets. What does it have to do with big O notation? Yes, but I haven't taught that yet, so I don't want to jump the gun. Because if I start throwing out big O notation, I'm going to confuse people, and I'm going to spend the rest of the lecture explaining that, and we're covering it next Monday. So I don't want to jump the gun. Hash sets are faster, but it does have to do with big O notation. So how do hash sets work? Why are hash sets so fast? This is where we need to spend some time, and I'm actually going to pop over to the slides. The idea of a hash set is that in addition to a toString method and an equals method, remember we've talked about the object class. The object class has a default implementation of equals object O and has a default implementation of toString. It also has a default implementation of a function called hashCode. Equals returns a boolean, toString returns a string, obviously. Hashcode returns an int. And that int is the heart of how a hash set works. The idea of the hashcode function is that it produces some unpredictable looking number based on an input. So the hash set takes in some information, produces a number. And there's actually some practical examples that we can show of this. For example, system.out.println. Let's do hello.hashcode. And this just produces a number. And that number is this number. That is 69,609,650. I don't know why there are so many sixes, but that's the value. This number, no matter how, it's not random, because no matter how many times I call hello.hashcode, it's always the same value. It's not different. It's not random, but it looks unpredictable. That is to say, if I give you a string, it would take you a long time manually to calculate what the hash code is, and it would look unpredictable. And the reason is this hash code is used in conjunction with something called a hash table in order to decide how to store things in a hash set. So this hashcode function takes in the object, whatever it is, takes its fields, and it produces a number. Does it always have to be 8 digits? No. No, the number just has to be an int. Any int is valid. So it could be anything from positive 2.1 billion, whatever that max number is, all the way to negative 2.1 billion. The number can be negative. From there, we decide where to place something in a hash table based on the result of a modulus operation. We'll talk more about that in a second. So here is, for example, how the string hashcode function works. The string hashcode function effectively, and it's not exactly implemented this way, but it might as well be. The string hashcode function is something like, public int hashcode. It's not exactly this, but it's close to this. Is int sum equals 0. And then for int I equals 0, I less than, and it's whatever the string is, dot length, which is the length of the string, I plus plus. You loop over every character, and you say something like, int c equals the string's character at I. But before you do that, it's sum times equals 31, and then sum plus equals c. Return sum. This is not exactly how it's implemented, but this is effectively how it's implemented. And it ends up producing a number that looks fairly random. Even though it's not random. If the same string always gives the same hash code. Now, as a result of this, we can then use that number to determine how to place things into hash tables. So a hash table, my camera's not connected. Where did my camera go? Oh, there it is. Give me 1 second. We did some cleaning over the weekend, and I forgot to put my camera back. That's not good. There we go. The legs are not... There we go. Okay. Sorry about the delay. So a hash table is actually implemented like a table. By that I mean we have a set number of rows. Let's say I have 8 rows, so that's 5, 6, 7, 1, 2, 3, 8. And each of these rows are numbered 0, 1, 2, 3, 4, 5, 6, 7. And you can think of these like buckets, where each bucket is initially empty. But from there, if I were to, let's say, want to add to the hash table, if I were to say I wanted to add to the hash table some value, what I would do, and by the way, you can't directly access this underlying table. Don't try to. You can't. It's private. But it's important to know how this works. Let's say I were to say words.addHello. Well, hello with a lowercase h is 99,162,322. Now, we don't have index 99,162,322. Our hash table is only size 8. So what do? Well, we do a modulus operation. And remember, this is the remainder. Divide by 8, what's the remainder? And that happens to be remainder 2. If you divide this number by 8, you will end up with remainder 2. And so we insert at index 2 the string hello. If I were to then say goodbye, lowercase g goodbye, that's going to give me, in this case, 207,022,353. Mod 8 is 1, so I put it in box 1. Add aloha, hash code for that, 92,908,957. Mod 8 is, sorry, not 1, it is 5. So I insert it in at position 5. So we're going to get to that, watch 77. We are going to get to that. So the idea here is that we have this hash table, and the things are put in an unpredictable order. But when we loop through our hash set, when we loop through it, we simply go through, we visit index 0. There's nothing here, we skip it. We go to index 1. Okay, goodbye's here. So we would print goodbye first. Then we go to index 2. Hello's here. So then we print hello. Then 3, nothing, skip it. 4, nothing, skip it. 5, we have aloha. 6, skip it. 7, skip it. Now the question that's being asked is completely valid. What happens if two things hash to the same value? So this is called a hash set collision. And this is unavoidable. You cannot, in almost any practical situation, avoid hash set collisions. Because given that the int has 4 bytes, there's only about 4.2 billion unique values for int. There are more than 4.2 billion unique strings possible. There just are substantial. There's a practically infinite number, technically finite, but it's an extraordinarily large finite number. In fact, sometimes you can have 2 strings that hash to the same value. In this case, system.out.println ugh, which is what I said when I woke up this morning, and Roman numeral 7. These don't just hash to the same bucket. They don't just have the same remainder. They are literally the same value. 84,982. They are literally the same value. So what happens in this case? Well, there's a number of ways to handle collision. The first way, and I'm going to go up to the whiteboard here. So does each string always have the same hash value? So I answered earlier that a given string always hashes to the same value because it's not random. So I've covered that, so I don't want to spend more time on it than I have. It always hashes to the same value. Ugh always hashes to that. And that's because we don't want it to be random. We don't want it to be. So let's take a minute and let's fill in our table as we have it so far. We had, pulling up my slides here. We had goodbye. We had hello. And we have aloha. Now, real quick, I just need to, does a longer string have a longer int? Potentially. Certainly small strings are going to generally be smaller. Larger strings could have negative numbers. They could have smaller numbers too. It's unpredictable. I could probably, if I had enough time, make a long string that hashed to 0. But it would take a bit of effort to get there. And that's just because remember that the largest possible integer plus 1 is the smallest possible integer. So it wraps around. So real quick, let me just do a quick... I'm going to see what ugh.hashcode mod 8 is. 6. Okay, so ugh hashes to bucket 6. So we're going to go up to our whiteboard. And we're going to add ugh into bucket 6. So now, when we add the element Roman numeral 7, there's 2 possibilities. And actually, there's actually 3 different ways that Java will handle this. And it depends on the situation what it does. The most common thing it does is it, instead of only holding 1 value in this bucket, it lets this bucket hold as many values as it wants. So the first value is ugh, and the second value would be Roman numeral 7. That's the easiest way to handle it, and that's how it's typically handled. There's another possibility where it will do what's called forwarding, and forwarding would be, well, if this bucket's full, just go to the next empty bucket. but there's a lot of difficulties that can emerge with forwarding. So don't really worry about how it works. I'm not going to ask you how it works. Just understand that every value gets put into a bucket. So now, let's talk about how the contains function works. Let's check if our list contains hello. We want to ask, okay, hello, does our set contain this? Java does not loop through this set to check if hello is there. Java does not loop through it. Instead, what Java does is it says, okay, if hello were in this set, if hello were in this set, is the bucket holding the actual string or a reference? Depends. The bucket is holding the actual value. When it's primitive, it holds the reference. It holds the reference for reference data types, which technically it can't contain primitive data types. It's string, so it is a reference to the string. Hello dot hashcode mod 8. It's going to check, okay. So that hashes to bucket 2. So Java will say, before it checks whether or not the hash set contains it, it says, if hello were in this hash set, it would be in bucket 2. That's what this prints, too. So, Java goes to bucket 2. It then goes, it checks the string, and it says, is this string hello? And it is. Hello is there, so it returns true. That's how contains works. Notice we never check 0, 1, 3, 4, 5, 6, and 7. Because if lowercase h hello is in this set, it must be in bucket 2. Otherwise, it would not be in the set. This is why hash sets are so much faster than lists. Because with a list, we would have to loop through the entire list. It is. It's more efficient than a linear search by a wide margin. Similarly, if we were to check how does contains work with forwarding, I'll get there. If we were to check VII, well, if we're checking for Roman numeral 7, that would be in bucket 6. So Java goes to the hash table, it checks bucket 6, it checks the first string, it says, well, that's not VII. It sees there's a second string, it checks that is VII, returns true. Let's say there was some other string that hashed to bucket 6 that wasn't UG or Roman numeral 7. Then it would check both of these, see neither of them are that string, and return false. How does it work with forwarding? I'm not. It's so complicated that I'm just not going to. I'm not going to worry about it because, it gets really complicated. Is all I can say. It really gets complicated with forwarding, but with just using by just making it a list of elements rather than a single element, that's fairly straightforward. The last thing I'll say is if it were to look for, let's say, cat. So cat hashes to bucket 6, not a good example. Let's try dog. Bucket 4. So if I'm looking for the word dog, I'm going to check bucket 4, and I'm going to say, oh, well, this bucket's empty, so dog cannot be in this set, returns false. If I were to come up with a word that hashed to say bucket 2, but it wasn't in bucket 2, it's false. So we only check one bucket. Therefore, because we only check one bucket, the algorithm contains is as efficient as the buckets are small. The smaller each individual bucket is, the faster contains is, because there's fewer elements to check. And Java does this automatic balancing where it will make the hash table bigger if the buckets get too full. No, the hash table in Java has as many spots as it needs. So it will grow in size, and rehash elements if it needs to grow. And that process is complicated enough. I'm not gonna jump into it for now. But I am going to just say, Java handles it. It will increase the size of the hash set in order to keep the bucket small. Generally, we have this measure called load factor. Load factor. And the load factor is the number of the load factor is the number of values. So this is mathematical notation for magnitude. That's the number of values divided by the number of buckets. And if this number becomes greater than, and for Java it's typically 0.75, if this number becomes greater than that, Java will increase the size of the hash table and rehash everything. So that way the buckets stay reasonably small. When it goes into a certain bucket with multiple elements, does it check those values in any certain order? No, not really. Not in any predictable order. And again, that's because when we're thinking about the hash set, we don't even want to know order exists. Like, technically, I have just shown you, technically there is an order to this hash table. But from a programmer standpoint, I don't want to think about that order. I don't even really care how the set is implemented. I just want it to be fast. And so that's how hash set tries to be used. So you never actually, while using the hash set, have to worry about how this hash table works. But there are some things you do potentially have to worry about when using a hash set. First and foremost, when using a hash set, you have to implement on the class that you're putting into the hash set a hashcode function. So if I were to say make a hash set of Pez dispensers, I should make my own hashcode function, and here's why. The default implementation, as we've talked about with equals, the default implementation is, are the objects the same memory address? And the default implementation of toString is name of class at memory address. And the default return value of hashcode is memory address. It is whatever number the memory address is. However, this won't work because the thing is, you could have two strings that have the same contents but different memory addresses. And if you have two values that are equal, if A equals B is true, then they need to hash to the same bucket. That's because if I use the memory address, I could have one string at a memory address that hashes to bucket 1. Say the string hello hashes to bucket 1 in one case, and the string hello hashes to bucket 5 in another case. If that could happen, my hash set wouldn't work. Because then I wouldn't be able to predict which bucket hello is going to go into in order to check later. So the rule is, if you define an equals method such that two objects A and B are equal, then they need to hash to the same bucket. Generally, the most common way that you will see a hash code done for any object, let's say I were to make a hash code function for Pez dispenser, actually, let me do point. I did point as an example. The easiest way to do, so here's my equals method for point. The easiest way to do a hash code function for point is just this. Public int hashcode return toString.hashcode. And you'll notice that my toString method produces a string based on X and Y. Because of this, if my x and y between 2 points are the same, I always get the same string. And if I always get the same string, then my hash code will always return the same value. So this is a way to do a hash code function. But there's a problem. For example, let's say I made a person class, and that person class had a first name and a last name. Let's say that I did hash code on first name, which is a string, plus last name. So I just concatenate the two, and then I do hash code. There's a problem here. You see, I recently got married, and my wife decided, of her own accord, to change her last name to my name. That means that her hash code would have changed. So she would have been put into the hash set as, and I'm making up the name here, this is not the name of my wife, but I'm not, without her permission, I'm not going to use her name. Let's say her name were Abigail Smith. That would hash to one location, and Abigail McBurney would hash to a different location. And that's because the last name is more likely to change than the first name. Just for cultural reasons. I'm not condoning, I'm not saying that's what should happen, I'm just saying culturally that's a common thing in the West for the woman to change her last name to that of the husband. Because of that, because this field within the confines of the West is likely to change, we should not include it in the hash code. And that's because it's possible that, say, Abigail Smith hashes to bucket 5, but then Abigail McBurney would hash to bucket 7. And that means that I would lose track of where this object is stored. It'd be like putting a book in the wrong section of the library. You couldn't find it without going through the entire library. You couldn't find it efficiently. So the hash code should use fields that are unlikely to change and fields that are used to determine a quality. So the rule here is if A equals B is true, then A and B both need to have the same hash code. Similarly, if a field is likely to change, do not use it in the hash code function. Those are your basic rules. That said, don't worry too much about this, because the only place this matters is the homework. And on the homework 2, we tell you very, very explicitly how to write your hash code function, such that if you just follow the directions, it's impossible to do it wrong. So you don't even need to understand this slide to do well on the homework. Are there any questions about this? Now I should note that a tree set is implemented as a balanced binary search tree. And if you don't know what this means, don't worry. We're going to talk about this. We're going to talk about this on the Tuesday of the last week of class. You will talk about this in 2150. So binary search tree we will cover, but we won't talk about balancing in this course. Don't worry about this for now. All you need to know in terms of the difference between hash set and tree set, hash sets are faster, tree sets have sorting. That's it. Any questions about anything on sets? Okay, so from there, we're going to have a brief challenge. And admittedly, this challenge is not well written, but this is going to be your challenge over the break. This is not the daily activity. And the way I'm going to describe this is effectively, you have adopted a new dog. Congratulations. It will arrive later today. Please open the box quickly. I don't know if they put holes in it. But when your dog arrives, you're going to have to name it. Now, you and your friends have already written an unordered set of strings, specifically a hash set, that has 50 names you've come up with. Now, there's also, you looked online, you found a set of the most popular dog names from 2019. That is 100 names. Now, the idea is this set of 50 names, you're going to draw the name out of a hat. You don't want to bias yourself. You're going to randomize it, draw it out of the hat. You've already written these names on cards. But you also want to potentially name your dog any one of the 100 most popular names. These are not yet written on cards. Now, your challenge is you need to figure out a set. Your output is the set string of cards you need to write. And it's not going to be this same set of 100 names. Because, for example, your set of names you've already come up with may include, say, Fido. And Fido is also on the list of 100 popular names. At this point, you do not need to create this card. But let's say that one of the most popular names is Lassie, and you have not considered Lassie. That means Lassie needs to be in your output. So if the name is in both sets, it should not be in the output. If the name is only in the set of 100 names, but not in the 50 names, it should be in the output. If, however, the name were, say, George, this is not in the most popular 100 names, then you don't need to make a card for George. So again, what I effectively want here is for you to produce a set of all the names that are in the set of most popular names. That is the second argument, top names, but that are not in the set cards. So work on that with each other. Hop in the Discord. We're going to take a 10-minute break, so I'll be back at 2:19. We will solve that problem, and then we will move on to maps. So we'll be right back. Not 2:25, 1 second. Alright, hello everyone, welcome back. So, let's just quickly work out what this function is going to look like. So my function, I'm just going to write it in here, would be something like, and let me get the exact signature here, because I'm just going to copy and paste it. Public, and actually this should be static, realistically, so I'm going to make it static. Public static takes in cards and top names. I'm going to make a hash set string out equals new hash set. And again, you can, whenever you're initializing, you can leave that blank. It will fill in string from the left-hand side. And ultimately, I'm going to return out. But what I'm going to do in the interim is for string name in top names, I'm simply going to say if not names.contains name, that is to say, if why does it not like that? Oh, sorry, cards. If cards does not contain the name, then out.add name. So to comment this, I'm going to create my output set for each top name. If it is not in cards, add it to output, and then this just returns the list of names I need to make cards for. Are there any questions about this solution? And there may have been other ways to do it, sure, but I actually very explicitly did not use a for loop here. And the reason I didn't use a for loop here is because this without a for loop is actually faster. Again, because the contains method is just so fast for a hash set. It's actually faster than looping through everything, as we talked about. Are there any questions? All right. So with that, that's it for sets. Now, let's talk about maps. So a map is very, very similar to a set with one key difference. A map, unlike a set, is not for containing one group of information. Rather, the idea of a map is to map one value to another. Here's an example, a very practical example. Public static void main string args. I'm going to create a map, specifically a hash map. There are two different kinds of maps, hash map and tree map, similar to hash set and tree set. Hash map is faster. This is exactly like a Python dictionary. So if you're familiar with Python dictionaries, it's exactly like that. Except the map has to map one data type to another. So I'm going to map a string to an integer. And I'm going to call this celebrity ages. And I'm going to need some help here. So what I'm going to do is I'm going to get a list of celebrities, and I am going to get their ages. For example, Patrick Stewart, who is the Captain Picard on Star Trek The Next Generation, which is on Netflix, and skip season 1. It's amazingly worth binging. Don't waste it. Season 1 is terrible. Season 1 is so bad. You can skip the entirety of it. But I guess technically you would not know who Tasha Yar is, but whatever. The rest of Star Trek is great. Patrick Stewart is 79 years old. So I can do celebrity ages dot put, and it's going to be Patrick Stewart and 79. And what I need from you, chat, are your favorite celebrities. Celebrities, not like pop culture, not politics, please. I don't want to go down that road. Celebrities only. What is their favorite age? Wow, you like Justin Bieber. Okay, whatever. To each their own. I'm not judging. Ages dot put Justin Bieber 26. I'm not a celebrity. Good try. Someone always tries that. I'm not a celebrity. Also, I don't go by the name Paul. I have not gone by Paul since high school. And actually, middle school. Okay. Zendaya. I'm not going to be able to type all of these, by the way. Zendaya. Uh, 23. I'm just going to pick a subset here. Samuel L. Jackson. He's getting up there. Only for some reason, I thought he was older than 71. I don't know why. Emma Watson's only 30? Huh. Fair enough. Also, by the way, I'm not 29. I thank you for the vote of confidence. I am not 29. I am older than that. I don't know why people think I'm 29. I don't know where that came from. Taylor Swift 30. I'm in my 30s, I will say. All right. So with that, now, oh, Stevie Nicks, that's a good one. Fleetwood Mac is awesome. I support adding Stevie Nicks to this list. Rumors is an amazing album. I said in my 30s. I didn't say I'm 30. I am not. System.out.println celebrity ages. And there we go. Taylor Swift, Patrick Stewart, Justin Bieber, etc. Rumors is such a good album. Anyway. The point is, this is exactly like a Python dictionary. You have a key like Patrick Stewart that, alright, fine, I'll add Young Dolph, whatever. I don't know. I keep in mind, once you go into grad school, you stop being able to keep track of pop culture. So I do not know. I could not pick Emma Watson out of a lineup. I just know there's someone who exists with the name Emma Watson. That is the extent of my knowledge. I could not name a movie this person was in. I'm old, okay? God forbid if I have kids, I'll be even more a lost cause. Anyway. The point is, the order of the keys is not predictable. And that's because the keys are stored in a set. Unlike Python, they are not stored in the order they are added. Harry Potter isn't that Daniel Radcliffe? Dude, I haven't watched the Harry Potter movies. I haven't actually read the books either. I don't have anything against it. I wasn't allowed to as a kid. And now I just haven't had a desire to go back and read it. Okay, cool. I'll go with that. Anyway, the keys are stored in a set. Each key maps to one value. That is, I will just say I grew up in that type of household. I do not support such notions. that you don't pick your parents. Anyway. So we can go through this set and we can see the key is to the left, the value is to the right. So we map a key to a value. From there, if I want to say get system.out.println, get the age of a particular celebrity that is in this set, I can do celebrityages.get, and then the key is going to be, let's say, Patrick Stewart. And that will unlock the value 79. If, however, I try to get a value that is not in the set, let's say, for example, Jonathan, let's go with Carrie Oyles, or Carrie Elways, who has been in stuff you've seen, but is really not a celebrity, if we're honest about it. I get null. Unlike, so in Python, if you try to access a dictionary value that doesn't exist, it crashes with a value error. In Java, it does not. It doesn't crash, it simply returns null. So, no, key not found produces null. What if two celebrities map to the same key? Well, here we go. Emma Watson and Taylor Swift. Taylor Swift is 30. Emma Watson is 30. There's no problem with that. But because the keys are stored in a set, each key can only map to one value. So the key Emma Watson can only appear one time. So let's say, for example, I'm pretty sure I would be very surprised if this were accurate, but maybe it's just because I'm old and I think everyone else is old that I've ever heard of. Point being, let's say, and again, this could very well be correct, but let's say we're wrong and we found out he was actually 27. What I would simply do is do celebrityages.put Justin Bieber 27 instead. And this would overwrite the existing value that the key Justin Bieber matches to and would replace it with 27, as you see here. So each key can only appear one time. It doesn't matter if a value is unique or not. Values do not have to be unique. Only the keys have to be unique. Make sense? To that end, exactly, it's like a function in math. It's like a function. Each value in the domain can only appear once. The values in the range can appear multiple times. Correct. So two celebrities with the same name but different ages could not exist. Correct. Does it print the value in the same order as HashSet does? I think so, but I'm not sure. But I can find out. System.out.println celebrityages.keyset. This gives me the set of keys. And yeah, it does print in the same order. So Young Dolph, Taylor Swift, Patrick Stewart, etc. By the way, because this is a hash map, this set is a hash set. If it were a tree map, this set would be a tree set. So again, hash sets may appear random in order, but they're not random. They are deterministic. They're just not predictable because they're not really ordered. There is no 0, 1, 2, 3, etc. But yes, they are in this order. From there, let's say I wanted to print every celebrity's age one at a time. I could do this by looping for string celeb in celebrity ages dot keyset. I have to say this part. dot key set. From there, I could say system.out.println celeb plus is plus years old. Celebrity ages dot get celeb. This is how I could loop over a hash set and get all the keys and all the values. Like this. Now, this get function lets me go from the key to the value. There is, by default, no function that goes from value to key. And that's because the values may not be unique. You could do it with a loop if you wanted, but it's not something you control. You can, however, access system.out.println celebrity ages dot values. And this will return a collection of integers. However, this collection is not really in any way meaningful in terms of the order. And this collection is defined as a collection. It's implemented like a list, but you cannot treat it like a list. So this hash map works like a Python dictionary. Now, let's write a function for practice. Public static void, not void, yeah, actually we'll make this void. We'll make this function destructive. Age 1 year. And this is going to take in a hash map of string integer people ages, we'll call it. And what I want this function to do, I want to go through the input hash map and increment everyone's age by 1. Here's how we would do this. We're still going to loop through our key set, so I can just copy this, except instead of celebrity ages, it's technically this function generic. It supports any group of people ages. Doesn't need to be celebrities. And what we simply need to do is we need to say, okay, get the current age, and then add 1 to it, and then put that new age back into the map. So, people ages, and I'm not going to call this celeb, I'll just call this P. People ages dot put P, and the value that I'm going to put into P is people ages dot get P plus 1. Now let's test this function. So I'm going to call age 1 year people ages. Not people ages, sorry. Celebrity ages. Age 1 year celebrity ages. System.out.println celebrity ages. And if I did this correctly, everyone will age 1 year. So we have this list: Young Dolph 34, Taylor Swift 30, Patrick Stewart 79. From there, run it. Young Dolph 35, Taylor Swift 31, Patrick Stewart 80. You get the idea. So this is how we could go through and modify everything in the map to be 1 greater. But the key is, you can't just modify it. Effectively, you have to get the value, apply whatever modification you want, and then put it back into the map. Because put overwrites any existing key value pair. Any questions about maps? And by the way, I'm not going to put these files online, but that's because I've already put a set examples and a map examples online that cover all the same material. They're just better commented. Will we learn how to code a map? Not in this class. No. In 2150, I believe you will make a hash map from scratch, but not in 2110. You do need to know how to use it. It's useful to have an idea of how this hash. Whoop, my camera fell over. Useful to have an idea of how the hash set works, and the hash map works a similar way, but you're not going to be required to implement one. You can always just use the existing hash map or tree map. So you don't need to. We're not, for instance, on the test, I'm actually not going to ask you to fill in a hash table. I'm not going to ask that, but it's worth knowing how it works because that's going to explain why it's faster than, say, a list. So get is not the same as values. Get takes in a key and returns a value. Takes in one key and returns one value. Values, did I delete that line? Values returns a collection of all of the values. But that doesn't give you one value, that just gives you all of them. You can't do like values Patrick Stewart. So they are very, very different functions. Get gives a single value. Values gives all of them, but they're not attached to the keys. Any other questions? All right, the daily activity today is on maps, but we're going to stop on maps there. We'll come back to it for the daily activity because I now want to start talking about testing. So, real quick, when discussing testing, I want to just take a moment and define why we care about testing. So, first, here is a question. Which of these two bridges has failed? Now, I want you to really think about this. Look really closely and see if you can find any telltale signs of which of these two bridges has failed. Now, this is a hard problem, so if you need help, jump in Discord, and other people can help you. But I'm going to take a minute. I want everyone to think about this, okay? All right, now, which bridge has failed? Is it A or B? A or B? Which bridge has failed? Well, yes, people have died on the Golden Gate Bridge, but it still functions as a bridge. It is A. Obviously, this bridge is not functioning as a bridge right now. This bridge has failed. This is not a trick question. I was being sarcastic. But now, which of these two bridges has failed? It is one of them. Which of these two has failed? I'm going to put, just so I have a delimiter. Is it A? Well, is it A or B? Which bridge has failed? One of them has. Neither of these are the Tacoma Narrows Bridge. Tacoma Narrows Bridge was a suspension bridge. Which of these two bridges has failed? And I want to be clear. Both of these bridges are what the bridges look like today. Both of these. They're not the same bridge. But both of these bridges have failed. Sorry, not failed. Sorry, both of these bridges are taken pictures as they look today. Both of these have not failed. It is actually A. A has failed. And it's not obvious. You cannot just look at A and say, oh yeah, this bridge has failed, but this bridge has absolutely failed. This is a bridge in my hometown of Charleston, West Virginia. This bridge has been standing for decades, and it has been unused for decades. This used to be an old railroad bridge across the Kanawha River. If you ever see it spelled, it's spelled like Kanawha, but it's just pronounced Kanawha. The Kanawha River is through the middle of Charleston. It feeds into the Ohio. It's actually a pretty major river. This railroad bridge went over it. It has not been used in decades. And there was a point where the city of Charleston said, all right, well, let's, it probably can't hold a railroad anymore, but let's do a study and see if we can make it a bike path. The foundation of this bridge is so damaged that to make it safely a bike path would cost basically a complete retrofit of the bridge. They'd more or less have to rebuild the bridge from scratch. So the plan was scrapped. This bridge is incredibly dangerous. You occasionally see someone trying to walk across it, and people are actually worried that they're rocking back and forth may cause the bridge to start to collapse. It's really, really unsafe. And by the way, this road, McCorkle Avenue, goes right underneath it. So it's actually a really big risk. This bridge very much has failed. And the point of this lesson is to say failure is not always obvious. It will not always be this obvious which of these two bridges has failed. Sometimes it will be this. And that's something you need to address with your code. In software engineering is inherently invisible. This is a fundamental difficulty. If you've ever heard the term no silver bullet or read the essay No Silver Bullet, the most obvious problem with software engineering is that it's invisible. Code is not easily seen. And it becomes not obvious then if a failure occurs unless you know what you are looking for. And this is a problem because software projects, as a result of these little failures piling up, fail all the time. This is a graph of something called the Standish Chaos Report. And if you look at a software project over its lifespan, there's 3 possible outcomes. It is successful, and that is the blue. It is challenged, which means that it is some combination of late, over budget, or missing key features. So like Assassin's Creed games. And then red here is failures. That means that no product was ever delivered. Now, obviously, you see a spike here in the 90s. This has to deal with the dot-com boom and burst. There was a lot of failure at this time, and it leveled out after that. But about 1/6 of software projects never deliver a product. Incomplete or otherwise. They just fail. Usually taking the company developing it with them. Our success rate rarely gets above 30%. By the way, I know this graph ends in 2012. This pattern's held true. Most software projects have some kind of challenge. They are some combination of over budget, late, and missing key features. And there are practical examples of this. I will give examples tomorrow. And so, what we need to do is we need to think of testing as a means to determine when our software is done. So my question to you is, some of you have already started working on the homework. Hopefully all of you have started. How do you know when your homework results are correct? How do you know when your homework's working? Do you ran it, it looked right? You compared results with a friend? You got output, so it's probably working. I mean, your code compiled, so it's got to work, right? I submitted on WebCat and got a 70 out of 70, so that I kept submitting until I got there, so it works. None of these strategies are actually good and scalable because here's the thing. Once you're out there building real-world software, there is no WebCat. There's no one who's going to look at your code and tell you whether or not it's correct. You have to do that on your own. And the only way to do that is testing. And if you have not been testing, then I find your lack of tests disturbing. Now, obviously what we don't do, obviously what we can't do is we can't exhaustively test our program. And I do have bad news. You are never going to be certain your code is completely correct. Even trivial software systems can have a theoretically infinite number of states or just an unfeasible number of finite states. Here's an example. Let's say you are writing a function called isValidDate, which you are going to do this on homework 2. But I want to be clear about this. While you're doing this on homework 2, the qualities that I'm about to lay out about why this function's so hard, you can ignore them, and the directions will say this. But consider a function that takes in 3 integers, a year, a month, and a day. We'll limit this to AD. Don't worry about BC. This is fairly easy, right? I mean, January, March, May, July, August, October, December, they all have 31 days. So you can just do a check for that. Then you have the 30-day months, April, June, September, November. February's kind of an asshole. February, you're going to have to do, like, is this a leap year, 1 to 28 or 1 to 29? But this seems like, if I gave this to you as a problem, you could probably write this, right? You cannot test this with every possible year, month, and day. You could not write this many tests. You could not test exhaustively. But you could design a set of test cases to check this. But here's the thing. This simple problem is actually quite difficult. For example, in chat, type it if you know it. What is George Washington's birthday? Simple question, right? You can just look it up. What is George Washington's birthday? Well, I'll not wait. I'll just tell you. His birthday is February 11th, 1731, and February 22nd, 1732. This is George Washington's birthday. And this is a factual statement. Calendars are weird. Let me explain. You might be thinking, wait, what? How does he have 2 birthdays? It's because there were 2 different calendars at the time that were prevalent. On the Julian calendar, George Washington's birthday is February 11, 1731. On the Gregorian calendar, it is February 22nd, 1732. At the time George Washington was born, and he was born in an English colony, therefore he, used the Julian calendar, they were still in the year 1731 on February 11th. That's because February on the Julian calendar was the 12th month of 1731. March used to be the first month of the year. On the Gregorian calendar, February was the 2nd month of 1732. Further, because there was the Julian calendar and Gregorian calendar were on different days, on the Julian calendar, it was February 11th. On the Gregorian, it was the 22nd. So often you will see George Washington's birthday written as February 11/22, 1731/2. This is how his birth date is recorded on official paperwork. Why am I bringing this up? Well, as I said, this seems like a simple problem, right? Just check if a date is valid. Well, here is England's calendar in 1752 in September. This is the actual calendar of England in 1752. Wednesday was September 2nd. Thursday was September 14th. There was no September 3rd through 13 in England in 1752. France and Spain had a September 3rd through 13, but not England. By the way, Russia didn't adopt the Gregorian calendar until the 1900s. So even Russia, I think, was still using the Julian calendar because they're the Eastern Orthodox Church and, Gregorian's Catholic, etc. Yeah, it would be nice if 2020 could get shortened like that. Sadly, can't be. And so the point of this diatribe is a very simple problem could very much have blind spots that you don't think to test. How many of you would have tested with September 5th, 1752 before you told us? You don't have to do this on the homework. You don't. Don't worry. In the homework, you can just assume the Gregorian calendar and just leave it at that. The point being, there could be these difficulties here that you don't even know about. And that's the difficulty with software testing. So the point of software testing is we're going to evaluate a piece of software with the intention of looking for defects and bugs. And the emphasis on executing and finding. We do not test software to prove it works. Because you can't do that. Because you could always have blind spots you don't know about. Like this calendar. When we are testing code, we are in the mindset of testing code for the purpose of finding bugs. What is the ultimate goal of software? To satisfy the customer. How do we make sure it's accomplished? With different types of testing. But now, starting today and into tomorrow, we are going to take time and talk about unit testing. I want you to look at this function, and I want you to tell me whether or not this function works. Takes in 3 numbers and returns the max. When you are confident with your answer, yes it works, no it doesn't, type it in chat. Does this function work? Okay, TFT is games. Why not? Why does this function not work? You said no first, so I'm putting you on the spot. No, because you can't do that, because Java is strongly typed. So that's not a problem. Because these are 3 ints. So you don't have to worry about that. Java wouldn't even compile. A is less than B equals C fails. So like A is 3, B and C are both 5. Returns A? That is correct. Actually, you can design a simple test case where this should be returned C. For example, if A were 3, B were 4, and C were 5, this would return 3. So this is a bug. But I assume most of you probably didn't catch it, or if you caught it, it took you a lot of mental effort to catch it. All right, here's another function. This is a max function. Takes in 2 numbers, returns the max. Does this work? Yes or no? Does this work? Yes or no? Some of you may be thinking, wait, what? How is this a max function? But this function works. It works fine. There are no bugs. Tell me 2 numbers, chat. Tell me 2 numbers. Let's keep them less than 100, please, for the sake of me doing mental math. 4 and 3, that's too easy. Let's do 4 and 17. Okay? 4 plus 17 is 21. The absolute value of the difference between 4 and 21, or 4 and 17 is 13. So plus 13, that is 34, divided by 2 equals 17. 45 and 62, okay? 45, 62. The sum of these 2 numbers is 7 carry the 1. That's going to be 117. Plus the difference between them is 17. That's 134 divided by 2 is... Wait, I did my math wrong. Sorry. This would be 107, not 117. I'm bad at math. 124 divided by 2 equals 62. This function works. It doesn't look like it works, but it works. And that's the key. You cannot look at code and tell if it has bugs easily. The best way to determine if code works is to test it like I did here with inputs and outputs. And that's what we're going to do tomorrow, and we're going to do it through JUnit. So we'll pick up from there. I'll end early today. And with that, we will look at the daily activity. So the daily activity is reverse phone book. Oh, hang on. Gotta log in. Okay. The daily activity today is reverse phone book. And you can make some assumptions here. Yeah, you can take quiz 3 now and be fine. Any day I release a quiz, I'm not going to have any future material on the quiz. The quiz is only going to reference that day and before. I'm never going to release a quiz on Monday that relies on content from Tuesday. I may do that with homework. But the homework, the point is you can get started on, say, Tuesday, even though we don't finish covering the concepts on it until Wednesday. But the quizzes, I will never do that. So with that, the activity today, and it says daily activity day 6 because day 5 didn't happen, but you are going to write a function that produces a reverse phone book. Now, you can make the following assumptions. 1, every individual has a unique phone number. That is to say, no two people have the same number. And actually, that's the only assumption that you need to make. I have not given you a starter file. What I want you to do is I want you to write your own file, give it whatever class name you want, make this function, although real quick, I'm actually going to make this function static. Sorry. Just to make it easy, it's a static function now. I'm going to make this function static. And you simply need to take in a map and effectively reverse it. So if it says something like Steve has the phone number 8675309, then you want a map that says value or key 8675309 maps to the string Steve. So hop in the Discord, work on that with each other, submit when you're done, but do test it. As we talked about today, you can make a small phone book, say of 3 names with 3 numbers, and then test to see if the reverse works. And from there, we will wrap up for today. I will stick around for questions, but I'm not going to introduce any more material today. So if you're heading out, take care, and I'll see you tomorrow. Does testing for homework 1 have to be in a separate file? No, it can be in the main method. It can be in the main method. In fact, I think the instructions encourage you to put it in the main method. All right. Failing to see any questions, I will wrap up the... Oh, since you set the guidelines for naming and commenting for homework 1, does it also apply for daily assignments going forward? You should practice those skills just to get into that habit, yes. give another minute here for questions, and if I don't see any, I'll wrap up. When should we expect our grades for previous daily assignments to be uploaded? I will meet with the relevant TAs today, and I'll see how the grading is coming along. They may. I will try to get an answer to that. I don't have one right now. Do we make 2 tests for each method we used in the homework? I would encourage it. And you can think of it, you want to make sure those tests are unique. So for example, add photo has 2 different possibilities. You're adding a photo that is not in the photos list, at which point it does one thing, or you're adding a photo that is in the photos list and it does another. So I would encourage you to design your tests that way. And you will be graded on the testing on that homework. That grading is done manually. Pardon me. All right. I'm not seeing any other questions, so I'll go ahead and end the stream for now. But I will be here. You can keep dropping questions in chat. I'll just type to respond. I'll see everyone tomorrow. Take care.